So let's see this particular question now. So in this question, we are given two binary strings, S1 and S2, and a binary string, as we know, can only contain zeros and ones, right? What we need to do is we need to add these two strings, like the numbers which are formed uh, by each of these strings, we need to add them, and then we need to find the resultant output as a string, right? So for example, if this is our input 1101 and S2 is 111, if I add these two strings, that is, if I add these two numbers basically, I will get 10100, right? And that's what I have to return as a string only, right? So that's what I need to do. I basically need to do a binary addition over here between two binary numbers, and those binary numbers will be given as strings to me, right? So that's the entire question. Now maybe you can just pause this video and try to think of a solution. And once you're done, you can just come back and check the solution here. Okay, so now to solve this particular question, let's first of all work out how did this addition actually work, right? How did 1101 and 111 by doing a binary addition between these two numbers actually yielded 10100, right? So for that, let me do one thing. Let me actually take a pen over here. So now we are saying that our numbers are 1, 1. Okay, let me just. So now we are saying our numbers are 1, 1, 0, 1, right? And then we have the second number as 1, 1, and 1, right? Now, if we need to add them, we have to be mindful of the rules of the binary addition, right? And before actually adding them, let's actually write down those rules, right? So for example, if I have 1 in my first number for that particular digit, at every digit, I'm talking about. So for example, at the current digit, if I have 1 in the first number and then for example 0 in the second number, then the result of this would be actually 1, right? 1 plus 0 will be 1. And let me also put a comma over here and write the carry for the next digit, right? So carry in this particular case would be 0 because the output is 1 and I'm not carrying anything, right? So now if I go to the next number, like the next combination, it could be 0 plus 1 now, right? I can get 0 in the first string and 1 in the second string. In that case also the result would be 1 and there would be no carry, right? Now if I talk about other combination, it could be 1 plus 1, right? In that case, my result would be now 1 0, right? It should be 1 0. But now what I will do is at the current digit, I will just keep 0 and 1 will be carried to the next digit, right? That's how it works. And I can have as a last combination 0 plus 0, and for that the output would be 0 itself and there would be no carry also, right? So those are the four combinations which we can get when we are actually adding two binary numbers, right? Those are the things that we have to keep in mind. Now let's come back to this particular thing, right? So now we are saying we have 1 and 1 at this particular digit. So by this we will get 1 0. That means I will write 0 over here, right? And 1 will go to the carry to the next digit, right? Now over here I have 0 plus 1, so that will be 1, correct? And there won't be any carry anyway. But then I also have a carry over here from the previous digit. So the result of this, which is 1, will get added to this 1, right? And again, it will end up being 1 plus 1. So now it will be 0 again over here, right? And 1 will again go to the carry like this, right? Now this is 1 plus 1 now over here. So it will be, right, 1 0, right? 1 will be going to the carry for sure over here. Now over here, the 0 that we got by adding 1 plus 1 will get added to the carry, right? Because we also have a carry over here. So then again 1 plus 0 will become 1. And anyways, we wrote the carry over here. So we have carry over here. And now we don't have anything left in the second string. So we just have 1 over here, and 1 plus 1, which is there in the carry, would again yield 0 and 1, like 1 0, right? So 0 and then there is no number, so I will just write carry over here at the last. So this is how we got 10100, that is this particular output, by adding these two binary numbers, right? So that's essentially what we have to do, right? Now, I mean, there are many ways of doing this. We just, I mean, knowing these rules, we can all code these rules basically in different if else statements, right? And that would actually give us the right output. But now the idea over here is to actually have some observations, and then using those observations, we can actually write some concise code, right? Without getting into too many if else statements, right? So essentially, see, at every digit, what we are doing is that we are adding these two numbers, right? So for example, and let's talk about integer addition now, right? So, I mean, obviously we are supposed to do binary addition, but let's say if at every digit I'm not doing the binary addition, if I was doing integer addition, then for example, at this particular point, I would have got 2, right? Over here, I would have got 2 because 1 is in carry and 1 over here. Here I would have got 3. Here I would have got 2, right? And similarly, I can get 1 or I can get 0 also, right? If both the digits are 0 and there is no carry, it will be 0. And if, one of the digit is 1, 1 is 0 and there is no carry, again it will be 1. So essentially, the first observation is that instead of doing the binary addition, if we do the integer addition of, at every digit, our result for that particular digit can essentially range between 0 and 3, right? It can be 0, it can be 1, it can be 2, it can be 3, right? And now the second observation is if we get 0 or 1 at that particular digit, there won't be any carry, right? For example, if I have 0 and if I have 1, my output, like even if I'm doing integer addition, it would be 1 and there won't be any carry, right? Similarly, if I have 0 and if I have 0, again the output would be 0 even through integer addition and there won't be any carry, right? So the observation is that for 0 and 1, I won't have any carry for the next digit, but for 2 and 3, I will have a carry, right? For example, if I have 3 ones over here, we had a carry over here. Similarly, if there had been just 2 ones, no carry, again, the 0 would be over here and then 1 would have gone to the carry. So essentially for 0 and 1, we don't have any carry. And for 2 and 3, if the result of at that particular digit is 2 or 3, there will be carry for the next number, right? So essentially what we can do is at every number, if I take sum of all the digits, right? Like this, I can do at every sitting on at any index of this particular these two strings, right? What I can do is I can take maybe s1 of I, right? If I'm at the ith index, let's say, then I will do s1 of I plus s2 of I, right? Plus I will do the carry. If there is any carry basically at that particular digit, I will add that also in this sum, right? And now I'm doing a normal integer addition over here, right? Now if I want to take the binary result from this particular integer sum, what I can do is I can actually take sum modulo 2, right? I can do sum modulo 2 like this. And this will essentially give me the binary addition resultant at that particular digit, right? How? Let's take an example of this one, right? 1 plus 1, so integer addition over here would be 2. If I do 2 modulo 2, I will get 0, and that's essentially what I'm asking for, right? If I do 0 plus 1 over here, for example, I would get, and of course there is a carry also, so it will be 1 plus 0 plus 1. So again, it will be 2. If I do 2 modulo 2, it will be 0. So of course I'm getting 0 over here. Over here, if you see, the integer sum would be 3. And if I do 3 modulo 2, I will get 1. And that's what I'm getting over here, right? So essentially the idea is that whenever my integer sum becomes 2, right, I should turn it into 0. I have to reset the counter basically. I mean, that's what we are meaning basically by taking this modulo. And that's what the observation is, that if I take the integer sum of, all the digits at that particular index, right, and then take a modulo, I will get the equivalent binary digit for that particular index, right? So I just need to take the sum modulo 2 after taking the integer addition sum, right? That's how I will get the digit at that particular index. And now how to decide what will be the carry for the next particular digit, right? So to take the carry, what I can do is I can take sum divided by 2, right? If I take sum divided by 2, what will happen is, for example, over here, the sum was 2, right? 1 plus 1, that is 2. Now if I do 2 divided by 2, I will get 1, and that is my carry also, right? Again, 1 plus 1 was 2, 2 divided by 2 was 1, so again 1 got carried over here. Now over here, if you see 1 plus 1, that is 3. If I do 3 divided by 2, again I will get 1, right? Because I'm doing an integer division. And then, so the 1 got carried over here. Again, this will be 2 and there will be 1 carry, and which will be written at the last. Had there been no like carry over here, there would have been just 0 and 1. Then the sum, integer sum would have been 0 plus 1, that is 1. And now if I do 1 plus 1 divided by 2, it would be 0. And that's why there would have been no carry, right? So that's how we can actually decide what is going to be the carry for the next, next digit by doing sum of all the digits at that particular index, divide by 2, and what will be the resultant digit from the binary addition at the current index would actually be, let me write it like this, digit would actually be sum modulo 2, right? So that's the algorithm, those are the observations that we have to actually write. And by this, we can just traverse from the right to the left in both these strings, and one by one at every index, we can just keep calculating the sum and then the digit and the carry using the sum that we calculated, right? And at the end, we can just, append the last carry, whatever we got. If it is kind of just 0, we can also omit it. If it is, 1, we can just append it at the last, right? So that's what we have to do, essentially. I hope you understood it. And now see, talking about the time complexity and the space complexity, see, we are just traversing both these strings together, that too, once, right? So there will be like just linear time complexity over here. It will be big O of n, right? And talking about the space complexity, we are not using any extra space over here. And so the space complexity will be order of 1, right? So that's it. That's for this particular solution. Now let's jump to our IDE and write a solution for this particular problem. Implement the solution that we discussed. So first of all, let me just declare a function over here, add binary maybe, and this will accept two strings, s1 and s2, right? And now what I will do is I will just declare a variable result, right? And I will initialize it with an empty string. So I will just keep appending every digit that I'm getting after doing the binary addition with this particular result variable, right? The existing content of it. And that's how at the end of the entire addition, I will have the final output in this particular result string, right? That's the purpose of this. And also I will just declare the carry variable to hold the carry at any index, right? And then maybe I will just capture the length of each of these strings, s1 and s2, in two different variables, right? Like this and like this, right? Then what I will do is I will just, declare two pointers, I and j, and I will initialize to n1 minus 1, that is the last index of s1, and j pointer I will initialize to last index of s2, right? So it will be n2 minus 1, right? Now what I need to do is I have to traverse, both these strings from right to the left, that is from the end to the start, right? So what I will do is I will just write a while loop over here, and my condition would be while I is actually greater than or equal to 0, right? Or it is j is greater than equal to 0, right? So that is what I'm going to write in my condition, right? I'm going to traverse until I have any element in either of the two strings. I will just keep traversing towards the left, right? And then what I will do is I will first of all extract the digit from string 1, right? And for that, what I can do is I can just write s1 of I. This will be my current digit. And also I will convert it into an integer, right? Because this will be a string, right? It is not an integer array or something. This is a string, right? So I will have to convert this particular element, this particular number that I got, into integer, right? And also I will just check if my I, that is the current index, is actually greater than or equal to 0, right? Because if I'm exhausted with all the elements of string 1, then this particular statement will give me an index out of the range, right? So that's why I'm writing this. And if it is really less than equal to 0, then I will just return 0 for this particular digit, right? And I will just do this. And also I will just copy the same thing to extract the digit from string 2 at the current index, like this, right? And I will just change digit 1 to digit 2, string 1 to string 2, I to j, right? And over here also I to j, right? Right. Now what I will do is at the current index, I will take the sum of the digits, which will be dig1 plus dig2 plus whatever is there in the carry, right? That's what I'm going to do. And then what I can do is now I can calculate the current digit, right? The digit at the current index by doing the sum that I got above modulo 2, right? Like this. And I will just convert this into string because sum modulo 2 will be an integer. So I will just convert this into string and I will concatenate it, kind of prefix it with the rest of the existing content of result variable, right? So that's how I'm going to keep appending whatever digits I'm getting at every index, right? And then to calculate the carry for the next digit, what I will do is I will just do a sum integer division 2, right? That's what will give me carry for the next digit. And at the end, I will just decrement both my I and j pointer by 1, like this, right? That's what I'm going to do entirely. And then once I have traversed all the elements of both these strings, right, what I will do is I will finally, just kind of concatenate whatever is the leftover in my carry after the last digit that I have seen, right? I will just concatenate that particular digit after converting it into string, of course, right, with my existing element of the result, right? I will just prefix that carry to result, right? That's what I'm doing. And now that's it. I can just return this result. This will be my addition of the two binary strings which were given in the input, right? So that's what we are doing. And let me check what's this error. Okay, I missed an equal to sign over here. So we are reassigning the result variable over here. So that's the entire solution to this particular problem. I hope you understood it. And now I will see you in the next video. Thank you.